Now, I told you there were two basic approaches to doing proofs. There's the stumble forward blindly, and then there's the work backwards from the conclusion. Well, let's look at the conclusion to begin with. The conclusion is E. Now, as you can see, E shows up here. So, obviously one way to get E would be if we did disjunctive syllogism. Now, in order to do disjunctive syllogism, we'd need this with a negation in front of that. So that would be one way to go about it. Now, having looked at that, we might try now the stumbling forward blindly method. So let's look at the premises and see if there's something obvious that we can do. Oh, my hand looks horrible on the camera. One thing we can do immediately involves line 3. Think about what you can do with line 3 to make it into something that you can simplify, and think about what that would give you. And one thing it would give you will allow you to do a syllogism involving line 1. Another thing that you can also do, and that you should do fairly immediately, is biconditional with this one, because biconditional with this one will turn it also into something useful, and then something that you can use with another thing that you're going to get from this line. I think that's enough clues on question 1 to be going along with. But one thing about question 1 is you don't need to do conditional proof. Conditional proof won't help. And we're going to pretend that you don't know how to do Reductio Ad Absurdum yet, because you might not. Okay, question 2, while we're here. Now this one, conditional proof will help with. So if you're going to do conditional proof, you would start by assuming the antecedent of the conclusion. So you would indent and assume P and write S, as we like to do. And then look at line 1 and you will see an immediate thing that you can do with that P now that you have it. That will give you this, and then you need to look at where Q and R show up. They show up here. You need to think, what can you do involving the consequent of a conditional? Well, maybe the negation of a consequent, and you need to think about what that is equivalent to by my favorite rule of implication. And then that should set up a sort of chain of events that's going to end you up, because remember, you on your last indented line, let's say line 20, you want to have Z, because then you can say on line 21, if P then Z by conditional proof 5 through 20, let's say, and you'll have the conclusion. Alright, that should do it for the first 2 questions. Let's pause there. This one, I think the obvious method to do this is by Reductio Ad Absurdum, because if you start by doing Reductio Ad Absurdum, you're obviously going to assume the negation of what you want to prove. You want to prove U, so you assume not U. By assumption Reductio Ad Absurdum. What that enables you to do, as I mentioned in class, is modus tollens with line 2, and also modus tollens with line 3. Then, as I also mentioned in class, when you do Reductio Ad Absurdum, the last indented line, let's say down here, line off the bottom, let's scroll this up in a very low-tech way. Let's say we're down on line 20, it won't be that much. You're going to want to have a contradiction, so something and the negation of that something. Now this could be U and not U, but it probably won't be. It'll probably be more like P and not P, or Q and not Q, or R and not R. One suggestion to you is that you're going to want to do disjunctive syllogism involving this. So you're going to want to have the negation of either side of these. And as I said in class, the negation of, say, if P then R is equivalent by implication to P and not R. If you remember in class, I said that should be obvious because this is saying that if P then R is false, because you're negating it. But we know there's only one circumstance where a conditional is false. That's when the antecedent is true and the consequent is false. So that's why these two are equivalent. The circumstances where not if P then R is true is when P is true and R not R is true. So if you can create this, you can turn it into this by implication. And notice that you already have P. And that's enough clues for that. Now with this one, it's not going to be a conditional proof. You're just going to have to do a regular old kind of proof. And as I suggested, notice that you can simplify both sides of this, you can simplify both sides of this, and you can use S with this one, and you can use T with this one. And that is going to give you something that's going to help you with this. I will give you a hint and say De Morgan's law is involved at some point. Another thing to notice is that you have S, and if you have S, you can make S or W by one of the inference forms, and then you can do modus ponens with this one. And eventually you're going to try and get X out of there, and you're not going to need to assume anything. And I think that's enough clues.